Good morning or good evening. I want to welcome you all. Thank you for taking the time to listen in here on this webinar. I have some practical info I just want to run quickly through. So after this session, I kindly ask you to answer a short survey regarding the webinar, so we have the chance to improve. Tomorrow, you also will receive an email, another chance to fill out the survey, but also bid the video from this presentation. There will be room for questions after the presentation, and in the bottom of the page you have here a Q&A button where you can type in your questions and I will look through them after we're done here. So my name is Vegard Haugan. I work for Kongsberg Seatex, and today's topic is Maritime Broadband Radio and expanding operation in remote areas. My overview here, I want to go through the radio itself and some facts, also different type, so the product family, and then I will move over to the performance of the radio before we share some user cases where MBR has been the solution. So looking at communication, we have, of course, some requirements. I've listed some of them, and of course, minimum loss of package data. And maritime, okay, it has to really work well in a maritime environment. We have some challenges when it comes to the marine sector, so oversea, that we don't have onshore. Also, if you're doing an operation and there is a vessel going in between and line of sight is obstructed, you don't want to lose your data, or you don't want to wait for it. You want to have that continuous stream going. And again, easy to operate, maintain, and install. So if we go to the challenges, we have this one, which I would say is by far the worst case, is the flat sea fading. So you want the signal to go from antenna A to antenna B. But due to the reflection of the sea, you will get interference. It could be positive, it could be negative, but the negative one can actually stop the communication from going, or you can lose too many packages. Another challenge is this near far. So if you have a vessel all the way in the horizon and one close by you, means that you need a highly dynamic radio to cope with this. And again, we are at sea, so you have movement. So waves will create a lot of movement on the vessel. And again, you need a dynamic radio to cope with these factors. And as I mentioned, if something comes in between when you're doing that, and it's a critical operation. To say a little bit about how we have solved this, it is a phased array system with a real-time steerable beam. And by having this possibility, we cope with most of the challenges. And to show you a little bit about the radio and how it works, as I said, it's the phased array antenna system. What you see here is actually the radio itself. So we have 60 antenna elements placed after a lot of testing that is controlled by 17 FPGAs, which means we have a lot of computing power to actually electronically steer the beam in a specific direction instantaneously. And it's all done in software, so meaning there is no moving or wear and tear. It's all electronically steered. If you look at the advantages by using this technique, on the left-hand side here, you have a traditional system. Traditional radio and traditional antenna shines out in 360 degrees, meaning that there is limited range you can get out of it. It is limited bandwidth, and it's for sure easy to monitor and jam. However, if you look at how the phased array beam form and pointing a narrow beam towards the other radio or several radios gives you the effect that we got a long range, got a robust link, high bandwidth, and it's for sure really difficult to monitor and jam. Some facts and numbers of the radio. It is a beyond line of sight system. I will come back to this later on in the presentation. The radio is purely IP based, meaning that out of the radio comes one cable with a traditional RJ45 connector that you put into your system on board. So the router, the switch, or directly to the sensor. And then you feed the radio with power, and that's everything. The throughput in the radio is 16.5 megabit. It is a point-to-point or a point-to-multipoint system. And last but not least, it has deterministic latency, which means that you control the network and you can always tell when your assets or the other end can transmit and how much they have in the network. So it's not like your regular Wi-Fi back home or VSAT or LTE. It is your local network that you own and you control, and everybody knows when and how they can transmit. So there's no surprises waiting for it. If you look at the range, we have two larger radios, as I said, and then we have a range of 144s. So if you look at this MBR 189, that was actually the one you saw inside. This has 60 antenna elements, and it's a sector antenna. So the 189 has an opening angle of 100 by 100 degrees. So within this, it can beam form this narrow lobe, depending on where the other radios are. The 179 also contains of 60 antenna elements. However, this one can beam form in 360 degrees. So it's omnidirectional. However, it's just the beam it sends towards where the other radios are. The 144s comes in 5 different off-the-shelf products. The difference here is they only have 4 antennas. So they have the same software, the same functionality. However, you will lose some range when you use 144 compared to the bigger brothers. So normally, and what we see out there is that typically setup can be one of the 144s towards 189 or 179. MBR is based upon civilian standards. We also do have a range with military standards. They are the same radios, and you can see the number goes again here. But again, the difference is military or civilian. I said I was going to come back to performance. Performance, without typically always question, not typically, but always all people ask about is range. And it's hard to say, well, it's 40 kilometers, because there's 3 things that it's determined the range. And that is type of antenna. As you just saw, we have the larger one and the smaller one. So a combination of these together with antenna height and also the throughput. So those 3 things will give you the range. And I want to show you what happens with the throughput. So if you go with maximum throughput, that is 16.5 megabit on a setup with 2 189s, where the antenna height is 35 meters and 25 meters, you have a range of about 55 kilometers, and line of sight is 42. So quite a good distance beyond. However, if you go down in throughput, you will increase the range. As you can see, we are here now over 60, and then we go down and down. So to out to around 75 kilometers with that setup, if you then have an aircraft, antenna height isn't really a problem. So looking at this graph shows the throughput of an aircraft going in 10,000 feet towards typical vessel. And there we have more than 200 kilometers with 8.5 megabit throughput. So of course, to have an aircraft or a larger drone available will increase the range drastically. Okay, that was the technical part. You've seen now the challenges we cope with, what type of radios we have. And now I will show you some user cases. And nowadays, everybody talking about autonomy, remote operations, AI, and whatnot. The cases I have here will just be where, as I said, the MBR was the solution. And I want to start with this one. This was done last year for Equinor. So we took a Hugin together with a USV. Unfortunately, we had to have a manned boat. We couldn't use the USV. So this was playing the USV. It was a HiPAP in the USV that communicated with the Hugin as it did the pipeline survey. And from the USV and to an antenna on a mountain around Bergen. In the office downtown Bergen, they were remotely into this radio and could monitor the whole operation. So if you look at the coverage, and their goal was to survey the pipeline all the way out to an oil field here, and then they went back and out again and back. So close to 400 kilometers of pipeline was surveyed remotely from an office here in Bergen. Another project was up in Svalbard. This is the Technical University in Trondheim. They made this buoy they call the Pope. You can see a picture of it here. So the whole idea here is scientifically, so they added the sensors they wanted. They had a radio in here, and this was going into the ice and was frozen in. So it was just drifting along with the ice, and they could pick up data by either using a boat when they were up there, a drone when they were flying, or an aircraft. Also, they had control with Iridium for where the buoy was. Further on up at Svalbard, we also have been flying for many years with UAVs. And this particular example here is for monitoring sea ice and growlers. So this is just the picture from the video in the drone. And then they're overlaying with their software. So then you actually can tell how much ice is it in this area and which the largest one. And by flying, utilizing their software and back and forth here, they can monitor the drift and what's going on in the area. So either that day or a week or 2 weeks, depending on what their mission is. And then we have remote hydrography. This was a user case, one of the first one actually, where we had a launch that was equipped with the MBR 179. On board, it was 2 IP cameras. It was a multi-beam, side-scan sonar, and ISS data. And all of this is inside, was supposed to be remotely operated and monitored from the mother vessel. So here you can see the mother vessel with the antenna installed. And when you look at it from the operation room on board, this is what they see. So live data from the multi-beam, the cameras, the ISS system, and a map. So first test we did, we managed 57 kilometers with one. The next with 2 launches, we did more than 20. So it all depends on where you are and how you do it, but great test, and they are using this. We have also military operation, and MMCM is going towards man out of the loop. So maritime mine countermeasure. This is a project we started with together with France and UK. So they wanted unmanned boats together with autonomous underwater vehicle, either operated from a vessel or from shore. But the whole idea here is, of course, how far can we get away from the minefield and still discover and destroy the mine and have a safe passage in. So just another example of how you can use it. And again, common operational picture. When you have one or several units out there and you want to cooperate and work together, if everybody sees everything in real time or near real time, of course that would benefit the operation. Because good communication, everybody is on the same page, you don't work from old information. So what you see here is the mother vessel with radios. They were transmitting their ACTIS radar, their cameras, as well as the rib was out. So the rib was transmitting their camera into the boat further on, and also a guy with a small inspection kit. So we have a small radio on the head with a camera that was also transmitted in. So what you see here is actually a live still picture from that operation taken onshore in the operation room. So that is great and valuable information for them. And last scenario I want to show is from November 2019. We have had a program here in Norway together with the Norwegian Coast Guard, the Clean Sea Association, and the Norwegian Coastal Administration. They want to increase their oil spill combating capacity, as well as other inspections that the vessels are doing. So their assets available boat is, they have the Coast Guard vessels. They got 12 of them with this setup. Coast Guard vessel either got a rib with an inspection kit, or they have a drone. And we also have 2 surveillance aircraft equipped with the MBR. So this scenario we played was, we had a grounded ship, there were oil spill, and there was a container adrift. So the vessels were tasked to try to prevent more oil spill and also get control over the container. And everybody here in the TOC, so the operations center, wanted to see this live. And not only what was happening in the aircraft, but they wanted to be able to toggle between all the different sensors and assets everybody had to get the picture. So if you look at the aircraft, inside this is a sidewell looking airborne radar that can detect oil. They also have a really great camera, infrared and electro-optical. They have AIS with overlaying map. If you look at the Coast Guard, they had a fixed antenna on board, but as I said, they could also have either a drone. So this is the drone they are using with the MBR integrated underneath here. And also they have the rib with the inspection kit here. It's hard to see, but on the top here is a small MBR 144 with a camera. On board the vessels, you also have different infrared or electro-optical cameras. You can have oil spill radars or other equipment that you want to share with the rest of the people in the group. So everything is here then gathered in a common operational picture. And as you can see by the monitor here, you could choose which type of camera you want to see from which asset. You can put in polygons and areas and drifting objects. You can chat, you can share orders or videos or what you need. But the whole idea here is that when somebody is doing something in here, everybody sees it immediately. Okay, demonstrator ranges. We touched that one, but what we saw is that we had up to 70 kilometers from vessel to vessel. And then depending on the aircraft altitude, it was anything from 120 to 300 kilometers. So quick and short conclusion here. MBR is a robust, safe, and reliable communication. And for any operation or asset you have, any application, I think we do have a radio that will fit in and you can utilize to actually increase the efficiency and safety in your operation. So to sum up here, I have one more slide for you. If you only focus on a problem, you might miss the easy solution. So with that one, I want to thank you all, and hopefully you have some questions, and I will, as I said, try to answer as many as I can. And if I don't within the 30 minutes, I will make sure to answer them by email to you. Thank you. Okay, that was a easy one. No questions asked. Have you looked at remote region SAR applications? I can't say I have looked into them, but of course, remote region, we have done SAR up in Svalbard, which is as remote as you can get. But I would say any operation out in the open is remote. So yes, for sure, MBR is your own network. You own the data. There's no connection to a VSAT or LTE or something that you need to have. So within your group, no matter where you are, you will have communication. Any radios FCC certified? Yes, they are. We are in a process, and we have now received FCC license for MBR 144s. So that range of different 144s, we now do have FCC license for. And we also have for Canada. We are currently waiting for an answer for a waiver we have for the MBR 189 and MBR 179. Due to the situation we are in now, I guess that will take more time. We were supposed to have that clarified in November last year, and we're still waiting. Okay, the aircraft, that was a Beach King 350. And if you can see that, yes, you can. Let me pop it up again. So there it is. So if you want to see more here, so the radio is underneath, camera in the back, SLAW radar within the pod. Oh. If a small unmanned boat is rocking in heavy seas, does this impair communication? So as I said, the MBR is really dynamic for this, and the opening angle in azimuth is -15 to +45. So even with heavy rolling, it still will find the other radios. So yes, we have tested in pretty rough sea with small USVs, and we still maintain communication. The problem is if the sea is that high that you actually are going down and are all the way gone for the other radio. Of course, we don't penetrate any sea or anything, so you have to wait and up and down on the waves. For submarines, I could apply this type of antenna to submarines in surface condition. Yes, for sure. We have the submersible unit for the 144 that is pressurized to 1,000 meters. And I've worked on submarines, so I know that should be sufficient. So when you surface, you can for sure get it up there and share info you might have or get info from others while you're in surface or snorkeling. Okay, next question. Do you see the interest in the radios migrating to anti-piracy rules too? It will mean more assets getting up on the radios and antennas. Could be a way to alert localized assets of the VHF. Yeah, we actually did anticipate with a Norwegian frigate in Aden during that piracy area we had. And the Special Forces fast patrol boats were equipped with the radio. They also had a helmet camera and of course radios on the frigate. And the whole purpose was that the operation room on the frigate should get a live video feed, voice to see what they were doing. And so it was for safety, but also for doing the report while the guys were out there. Imagine 8-9 hours jumping around in high-speed boats. You don't want to start with your report when you get on board again. So that was running 6 months down there, and really great. Is the supply of MBR back to normal now? Oh yeah, okay. We have been taking some actions and we have a 2-shift going on the factory. However, there might be some delays in getting third-party equipment, but so far we are up to speed and managed to supply what's asked. Okay, if the MBR will be considered into e-navigation compared with VDS, of course that is 2 different things, I would say. I think AIS and VDS will go its own way, but the throughput and the user, I don't know, I wouldn't say friendliness, but how MBR works compared to VDS, I wouldn't compare them. Okay, have been in seas, North Sea, where on a 50,000 deadweight ton, people were looking up to the sea. Add some challenges. Yes, that's true. Of course, when you have that weather, it is a challenge, definitely for vessel to vessel. But I would say in most of those cases, you need the aircraft to either pick you up or get you rescued. And there we have the ice. Okay, 15 minutes, 15 seconds left here. I want to thank you all for asking the questions. Hope to enjoy, and please answer the Q&As and the survey. The survey will be really great for us so we can improve. With that, have a great day. Thank you all.